The International Space Station, or ISS, is one of the most amazing things ever built in space. Orbiting high above our planet, it serves as a symbol of human achievement and international cooperation. The ISS is not just a laboratory, but a home and workplace for astronauts from all over the world, circling Earth every 90 minutes. But what holds this massive structure together, allowing it to function as a single, unified station? The answer is the integrated truss structure, often called the backbone of the ISS. This truss is a marvel of engineering, stretching the length of a football field and supporting the station's most vital systems. This giant framework was not sent up all at once. Instead, it took more than a decade, with many space shuttle trips and years of hard work to build it piece by piece. Each mission brought up new segments, carefully planned and coordinated by teams on the ground and in space. The truss is more than just a frame. It holds the station steady and strong, acting as the main support for the ISS. It also provides mounting points for solar arrays, radiators, and scientific equipment, making it essential for the station's daily operations. Each part had to be carried up by a shuttle, then connected like a giant puzzle by astronauts working outside the station. These spacewalks, or EVAs, were some of the most challenging and dangerous tasks ever performed in orbit, requiring precision and teamwork. Every mission brought new challenges and new pieces to add. Sometimes, astronauts used the station's robotic arm to help move and install the massive truss segments, demonstrating the power of human-robot collaboration in space. Without the truss, the ISS would not be possible. It lets the station spread out its solar wings, keep cool with radiators, and support science labs and living quarters. The truss is what allows the ISS to grow and adapt to new missions and discoveries. The team who built it came from many countries, showing what teamwork in space can do. Engineers, scientists, and astronauts from around the globe worked together, overcoming language barriers and technical challenges to create something truly extraordinary. This essay will take you on a journey through the story of the ISS Truss. Let's see how astronauts and robots built the backbone that keeps the station alive, and discover the incredible teamwork and innovation that made it all possible. The truss is a long, metal structure running the entire length of the International Space Station, stretching out like a backbone in the vastness of space. It's one of the most important parts of the ISS, yet it often goes unnoticed compared to the station's modules and solar panels. Think of it like the spine of a human body. Just as your spine gives your body shape and support, the truss gives the ISS its structure and strength. Just as your spine supports your head, arms, and legs, the truss supports the station's massive solar panels, radiators, and science labs. Without it, these essential parts would have nowhere to attach. It is made from strong, lightweight materials, like aluminum and titanium, chosen for their ability to withstand the harsh environment of space while keeping the station as light as possible. The truss is not one solid piece. Instead, it's a series of smaller segments, each carefully designed and built to fit together in orbit. Astronauts assembled these segments during spacewalks, connecting them like giant pieces of a puzzle. When seen from Earth, the truss looks like a giant bridge floating in the sky, stretching across the station and giving it its iconic shape. The main job of the truss is to hold the solar arrays far from the station. These solar wings need plenty of space to spread out and catch as much sunlight as possible, providing power for everything on board. The truss also holds large radiators that keep the station cool by releasing excess heat into space, which is crucial for the safety of the crew and equipment. Pipes and wires run along the truss, carrying electrical power and cooling fluid to every part of the ISS, connecting all the modules and systems together. Without the truss, there would be no place to mount these big systems, and the ISS simply couldn't function as a home and laboratory in space. It acts as the backbone, helping the ISS stay balanced and working smoothly day after day, making sure astronauts can live and work safely as they orbit high above Earth. Building the truss was not easy. The parts were too big to launch all at once. Instead, astronauts carried them up in the space shuttle over many years. Each mission added a new piece, like building a bridge in the sky, one section at a time. Astronauts had to leave the safety of the station to work outside in space. These spacewalks, called EVAs, were long and tiring. The truss parts were large and heavy on Earth, but in space they floated. Still, moving them with spacesuit gloves was hard work. The crew used robotic arms to lift the truss segments out of the shuttle. Then, astronauts guided the pieces into place. They connected bolts, hooked up wires, and checked every part to make sure it was secure. Sometimes this took several spacewalks for a single segment. Every step had to be perfect. If something went wrong, it could delay the whole build. But through practice, training, and teamwork, the astronauts made sure the backbone of the ISS grew strong and steady. One of the biggest and most important jobs for the truss was to hold the station's massive solar wings, which are absolutely essential for the International Space Station to function. These large, gleaming panels collect sunlight and turn it into electrical power for the ISS, providing energy for everything from life support systems to scientific experiments and daily operations. The first big solar array, called P6, was added in the year 2000, marking a major milestone in the station's construction and its ability to support a permanent crew. It was a huge moment for the station, as it meant the ISS could finally generate enough power to expand and support more modules and astronauts. Installing the solar arrays was tricky and required careful coordination, as astronauts had to work in bulky spacesuits while floating hundreds of kilometers above Earth. The panels had to be folded up tightly for launch, then carefully unfolded in space like a giant accordion, a process that took hours and demanded precision. Sometimes things did not go as planned. The complex mechanisms could jam, or the panels could snag, creating tense moments for the crew and mission control. In 2007, astronauts discovered a torn solar panel during deployment, which threatened the station's power supply and safety. This was a big problem, as a damaged panel could mean less power for the entire station and put future missions at risk. Without the panels working at full capacity, the station could not get enough power to support all its systems and crew. The team on the ground and in space worked quickly and creatively to come up with a solution to fix the tear before it got worse. Astronaut Scott Parazynski went on a risky and unprecedented spacewalk, riding at the very end of the station's robotic arm to reach the damaged area. He used specially designed tools, including makeshift wire cufflinks, to carefully patch the torn panel and prevent further damage. It was a tense moment for everyone, but the fix was a success, and the station's power was restored. The solar wings could now stretch out to their full impressive size, capturing as much sunlight as possible to power the station. Now, the truss holds 8 huge solar arrays, each one as long as a basketball court, making the ISS a true marvel of engineering. Together, these solar wings make the ISS one of the brightest objects in the night sky, a shining symbol of human ingenuity and teamwork orbiting high above Earth. Working in space is never easy, and building the truss came with big challenges. First, there is no gravity in orbit. Parts do not fall, but they do not stay still either. Astronauts had to learn how to move large objects that could float away with even a small push. Each piece of the truss was made to fit with the others, but in space, even a small mistake could make assembly hard. Astronauts wore thick gloves and worked in bulky spacesuits. This made it tough to handle small bolts and wires. Another challenge was time. Each spacewalk could last up to 7 hours, but the crew had only a short time to finish each task before they had to go back inside. Sometimes, they found surprises, like parts that didn't fit or tools that floated away. Despite these problems, the team always found solutions. Planning, training, and teamwork made the difference. The truss became a symbol of what people can do when they work together, even in the toughest place of all. The truss had to be strong enough to hold massive solar arrays in labs, but also light enough to launch into space. Engineers use special metals like aluminum alloys. These materials are strong, light, and do not rust. Every kilogram saved meant more room for science. Each truss segment was carefully designed on computers before being built on Earth. Engineers made sure that every bolt and beam would fit perfectly in orbit. They tested models in labs and even hung them from wires to practice weightlessness. Connecting the truss parts in space was like building a giant erector set. Some pieces were as long as a city bus. They had to snap together with bolts and latches. If even one connection failed, it could put the whole station at risk. This careful engineering made the truss both sturdy and light. It shows how smart design and teamwork can solve the hardest problems, even in outer space. Astronauts did not build the truss alone. They had help from robots, especially a giant robotic arm called Canadarm2. This arm can move heavy parts, turn bolts, and even carry astronauts. Canadarm2 was controlled by astronauts inside the station. It could grab truss segments from the shuttle's cargo bay and move them into place. Sometimes, it even walked hand over hand along the truss like a giant mechanical monkey. The arm and the astronauts worked as a team. While astronauts made fine adjustments during spacewalks, Canadarm2 did the heavy lifting. This teamwork saved time and kept astronauts safe from floating debris. Working with robots in space is now standard practice. The ISS Truss build proved that humans and machines can do amazing things together, even hundreds of kilometers above Earth. Today, the truss is still the backbone of the ISS. It stretches over 100 meters across, longer than a football field. It holds up the station's solar panels, keeps the labs cool, and supports cameras, antennas, and science gear. The solar arrays attached to the truss give the ISS all the power it needs. The radiators send away the heat from computers and experiments. The truss also provides places for new parts, like extra labs or docking ports for visiting ships. Without the truss, the ISS would be much smaller and weaker. It lets the station grow and change as new missions arrive. The truss has lasted for over 20 years, showing the strength of its design. The ISS Truss is a vital part of daily life in space. It helps astronauts explore, discover, and learn more about our universe every day. The ISS Truss is more than a piece of hardware. It is a symbol of what people can do together. Building it took many years, many nations, and many brave astronauts. Each bolt and beam tells a story of teamwork and invention. The truss stands as a marvel of engineering. It shows how humans can build in places once thought impossible. It inspires new engineers and explorers to dream even bigger. Every night when you see the ISS pass overhead, you are looking at a true wonder of the modern world. The truss holds it all together, keeping the station alive, strong, and ready for the future. The backbone of the ISS is a reminder. When people work together, there are no limits, not even in space.